There's lots of ways to look at that. So basically we use water in beef production to grow forage and to grow some of the feed that we add to the diet at certain stages of their production. Obviously cattle are going to drink water from various sources, and then we use water as well in meat processing, which a lot of that water is actually recycled at the level of the packing plant. But we might ask, well, where does the water come from? And that's a very good question. There's a lot of different ways of looking at this and analyzing it. But let's just look at forage. Majority of the cattle's diet throughout its life comes from grass and things that they eat out on the pasture. That's basically rainfall that falls right there in that ecosystem. It's not really lost. I mean, it's not competing with us for water use. You know, there's grass in a pasture, that water's not available for your faucet when you turn it on. Some people might call that green water. I've seen it called that. They will consume some water drunk from wells pumped out of the ground. There will be water pumped out of the ground to irrigate certain crops, or some cropland, and some forage land is irrigated. But as a percentage of the water that's used in cattle, that's really pretty small. So some people might call that blue water. And then again, I mentioned the water that's used in processing. So the majority of forage, byproduct, and even a lot of the grain that they consume comes from rainfall. You know, there's only about 15% of the corn grown in the United States is actually irrigated. So, you know, 85% of the corn that's grown is actually grown from rainfall. So basically we're capturing rainfall that's really not competing with humans because it's not being pumped out of the ground or diverted in a river or anything like that. So to answer that question, some of the better sources that I would find that have actually gone and looked at this question, from the time a calf is born to the time he's harvested, counting his mother's water use and the bull's water use and all the things that go into producing that calf carcass at slaughter, from the time that calf is born to the time he's harvested takes about 421 gallons of water to produce 1 pound of boneless trimmed beef. So again, how much water do cattle use? It's consumed as forage, feed manufacture, drinking water, and meat processing. Okay? So let's again look at this concept of rainfall as part of that. Green water, if you want to talk about it that way. You can see in this little picture here, the rainwater in this little system here is not destined for human use. Most of it stays right where it fell. It either stays on the soil to grow the grass that the cattle are going to eat, or some of it might run off and be captured in a pond or something for drinking. Now, you know, some of that will evaporate, but most of that, some might call green water, stays right there. So of that 421 gallons in the whole production cycle, you can see this slide, we've talked about the various stages of beef production. About 95% of that 421 gallons is actually used for the irrigated portion of growing feed. So again, that's the irrigated portion of feed. Cattle use a variety of resources. We've talked about byproducts and stuff before, but this is just a picture of that, of all the production phases from feed production to cow-calf sector, feedlot, processing, retail, and consumer. There's various water uses in all of those stages, and there is room for improvement in all of those. We can improve irrigation efficiency for crops. We can improve irrigation efficiency for irrigated forage. We can improve efficiency. We talked about growth implants a minute ago at the feedlot, for example, or even at the cow-calf level. That all improves efficiency of production and resource use, of which water could be one. So mention that water pumped or diverted maybe from a river for irrigation is indeed a cost to humans, because that could be used for some other source, whether it's manufacturing or our own drinking water or whatever. It could be considered a cost to humans. So water is used to grow crops like corn, cotton, soybeans, but the water used for those crops is for human consumption. You know, a farmer plants a field of cotton to make my shirt. That's water use attributed to my clothing, okay? There's all kinds of leftover stuff out there in the field, from the cottonseed to crop byproducts, you know, standing stalks of corn or whatever. That's what we call byproduct, and we've talked about that some earlier, but that is almost free water into the cattle production system. So cattle do consume some grain. We know that, probably about, in the life cycle of the animal, probably about 15% of the total diet might be grain at some, you know, during the finishing phase. So if cattle consume grain or forage crops as irrigation, we could count that as a water cost. Again, if these crops are raised for human food, the byproducts of that production, like cottonseed distillers' waste from grain production, bean meal from oil seed production, basically that's, again, as we said, that water's already been accounted for other uses. If these byproducts were not fed to animals, and the water that was held within those byproducts, like corn stalks or something like that, it would basically have to be disposed of as trash, either plowed back into the ground or maybe hauled to a landfill after processing or something like that. So as I said, only about 15% of the U.S. corn land is irrigated. However, that does account for about 20% of U.S. corn production. The U.S. produces about 25 million pounds of beef and about 200 million pounds of milk per year. They only use about 17% of the grain, whether it's irrigated or non-irrigated. Only about 17% of the grain produced goes into those systems. Probably, maybe even 30% might even go into something like ethanol production for cars or something like that. So for every pound of human food that is produced, there's another pound of byproduct or co-product that is produced by growing that crop. Again, we listed some of those byproducts. If those weren't fed to ruminant animals or even non-ruminant animals like chickens or hogs or something like that, if they weren't recycled through livestock, how would those be disposed of? Well, there's really only about 3 ways. We could haul them to a landfill. According to the EPA, from 2008 to 2012, about 134 million tons of human municipal waste went into landfills. If we were to dispose of crop byproducts by hauling them to a landfill, that would more than double the amount of waste that we're putting into landfills. So that's really not a viable disposal route. The other way we might think of disposing of byproducts if we didn't feed them to animals would be composting, or maybe burning them for electricity, you know, using the byproduct there. But that's going to cause a tremendous amount of carbon release. We know burning stuff releases carbon. Why not capture that carbon in animal tissue and recycle it through the system? So again, I think if we look at, really there's 4 ways to dispose of crop byproducts. We can put them in a landfill, we could compost them, which would again cause decay and carbon release. We could burn them, or I would say that the most efficient thing we could possibly do with them would be to recycle them through an animal and turn them into human food that way. Another thing that's important to look at, you know, there's lots and lots of numbers out there that talk about things like water use in beef cattle. And so it's important to use numbers that are relevant to our beef production system. Here's some contrasting numbers here. You know, this information on the left says that the boneless beef yield from U.S. beef production is 441 pounds. Well, in reality, the U.S. average is about 605 pounds. So that gets back to efficiency, right? Slaughter weight, 943 pounds. Actually, steers that we slaughter now are closer to 1,300 pounds when they reach slaughter weight. So it's important to use numbers that are representative of the efficiency that we have in U.S. beef production, which again gets back to some things we talked about, technologies for improving feed efficiency and growth and things like that. We might see numbers out there that talk about the water used per gram of protein or gram of calories produced for food. And you can look through these numbers. Let's just talk about liter of calories, water to grow a sugar crop. So you can see at the top here, it takes about 0.69 liters of water to grow a sugar crop, whether it's sugar cane or beets. Might take 1.3 liters of water to grow a vegetable crop. So that, when we contrast it down here to meat or dairy products or eggs or anything like that, you can see that there's a large jump in the water use. To grow an equivalent calorie of eggs, it goes from a vegetable at 1.3 to 2.3, basically, doubles liters of water to produce that. So that sounds like a lot. We get down here to beef, that's at the sort of the top there. It goes from 1.3 liters of water to grow a calorie of vegetables versus 10 liters of water to grow a calorie of beef. So that sounds like a lot. But let's back up and look at some of the, I don't know, biology or ecology that we all probably had in high school biology. Only about 10%, I think we learned in our high school biology classes, only about 10% of the food in a food pyramid is transferred between trophic levels. So you've got, we all learned there's plants at the bottom and the herbivores eat the plants, and 10% of that food energy is transferred each time. So the question might be asked, is it inefficient to use water or other resources? It doesn't have to necessarily be water, but since we're talking about water, is it inefficient to use water and other resources to feed grain to livestock when people might use it more efficiently by just going out to the cornfield and picking an ear of corn and eating it? And that's just diagrammed here. Well, that's just one little slice of that whole ecological pyramid. What we really have in this pyramid, like we said, about a small, 12-15% of the actual corn grown is going to be fed to cattle, let's say. But we've got all these other resources here at the bottom of this ecological food pyramid. We've got primary producers in the form of grass. We've got primary producers in the form of other crop products like cotton. So these add to that whole system. So it's really more efficient, synergistic, if you will, to add these other feedstuffs into that calculation. So it shouldn't be a direct calculation. We're taking a little bit of corn, let's say, or wheat or whatever that might be directly consumed by humans, but all the other byproducts we talked about add to the efficiency of that overall use. And again, by adding some high energy grain to the overall finishing diet, we improve the efficiency of the use of those other feedstuffs that you and I probably would not be able to ever digest. Another thing that I like to point out to people, in arid environments where we're not capturing a lot of the livestock water that we use in beef production, like on a cow-calf ranch, a lot of that water is captured in the form of ponds and tanks. But in more arid environments, we do have windmills and we do have solar wells, and we pump water out of the ground, and they do use a little bit of drinking water. Again, in the overall scheme of things, drinking water is a very small fraction of what total water use is to produce beef. Again, most of that is in irrigated feedstuffs. But let's talk about some of the other things that might benefit. Wildlife in arid environments, water is not predictable. And so if we can have permanent water sources in arid environments, all kinds of wildlife benefit. Everything from, like the elk in this picture, he probably took a drink there before he went swimming, but he's enjoying that water tank provided by a rancher. Many ranchers will allow their water catchments to overflow onto the ground for small animals like birds and rabbits and the whole environment there. So that's another sort of secondary benefit to having cattle out on the landscape, utilizing green water, rainfall to grow forage and things like that. So,
if we eliminated animal food production, couldn't we just use the water that we have for crop production instead?
yes, and we do. You know, we do. Anytime we grow a corn crop for tortilla chips or corn syrup or any of that stuff, we're using that water directly. But let's just say again, we have to look at the whole ecosystem rather than just one slice of the ecosystem. So again, having those animals there to maximize all the resources in that ecosystem and help funnel those on up the food chain, if you will, to humans is really the most efficient way to use water and other resources.